In this video, we are going to see how to use an operational amplifier as a summing amplifier. What is an adder or a summer? Suppose I have two inputs or more than two inputs. I need the addition of two inputs. I can go for an adder or a summer circuit. So if I design a summer circuit using op-amp, I call that as a summing amplifier. That is, instead of one V2, I may have V3, V4, some other voltages also. So I want to do the addition of these two voltages. I have to design a circuit using op-amp. So that circuit we call it as a summing amplifier, which will output a voltage that is proportional to the sum of the input voltages. So we will see how to design this summing amplifier. So depending upon how the inputs are applied, that is whether you are applying the input to a inverting pin or non-inverting pin, it is classified into inverting summing amplifier and non-inverting summing amplifier. Let us recall what is inverting amplifier and non-inverting amplifier first. In inverting amplifier, the input voltage is applied to the inverting pin, that is the negative pin, and the other input is grounded. And the output voltage expression in this case is minus Rf by R1 into V2. The output voltage expression has been derived in the video chapter 3 inverting amplifier. If you want, you can refer to that video. In case of non-inverting amplifier, the input is applied to the non-inverting pin and the other input is grounded. So in this case, the output voltage is given by 1 plus Rf by R1 into V1. And again, the derivation has been already derived in this chapter for non-inverting amplifier. First, let us see about the inverting summing amplifier. So here you can see several inputs or three inputs are connected to the inverting input pin and the positive pin is connected to the ground. Now let us write the nodal equation. Here the node B is connected to the ground. So node A will also be at ground, or it is said to be at virtual ground, because there are two golden rules for an op-amp. According to it, this difference voltage will be always equal to 0. That is, if this potential and this potential will be same. So since node B is at 0 potential, node A is also equal to 0. So at node A, the voltage is 0. Now we will write the nodal equation. So it should be V1 minus VA by R1. Since VA is 0, I am directly writing V1 by R1 plus V2 by R2 plus V3 by R3 plus V0 by RF is equal to 0. You simplify this one and find what is V0. V0 is equal to minus Rf by R1 into V1 plus Rf by R2 into V2 plus Rf by R3 into V3. So we got the output voltage expression. So let us see what happens if all these resistance are equal. That is R1 equal to R2 equal to R3. What will be the output voltage? V0 is equal to, so instead of R2 and R3, I am substituting R1. So I will get V0 is equal to minus Rf by R1 into sum of these three input voltages. Okay, so directly you are getting this output expression if all the resistance are equal. Now let us have a challenge. You need to design a circuit to find the average of the three inputs. So we saw we have three inputs. We have to find the average of these three inputs. So what is the average of three inputs? 1 by 3 into V1 plus V2 plus V3. So how to change these resistor values so that my output will be something like this. So what is the output expression we got? V0 is equal to minus Rf by R1 into V1 plus V2 plus V3. Now we want this as the output. It means that this Rf by R1 should be equal to 1 by 3. It means that R1 should be equal to 3 times Rf. So if this condition is met, we can find the average of the three inputs. So if R1, R2, R3 is equal to 3 Rf, you will get this expression as the output. So you will get a negative sign because it is a inverting amplifier. Now let us see about the non-inverting summing amplifier. So in this case, the input voltage is connected to the non-inverting input and the inverting input is connected to the ground through the input resistor R. What is the voltage expression for a non-inverting amplifier? V0 is equal to 1 plus Rf by R into this particular voltage, Va. But we don't know what is this Va. We have to find what is this voltage Va. First, let us mark this node voltage B because Va and Vb will be equal. So, if you don't know Va, we have to find Vb and Vb is always equal to Va. So, at node B, let us write the nodal equation. V1 minus Vb by R1 plus V2 minus Vb by R2 plus V3 minus Vb by R3 equal to 0. So in this equation I can substitute instead of Vb I can write Va because Va equal to Vb according to the golden rule of op-amp. So now let us simplify this one. Take Va outside. Va is equal to, you will get this one. So in this case, what is the output voltage? 1 plus Rf by R into Va. Now we got this Va here. Let us substitute it here. You will get the output voltage for the non-inverting summing amplifier. So here also you see R1, R2, R3 are there. If the resistance are equal, what happens? Let us see. If all the resistances are equal and these three resistance are equal to this input resistance and this feedback resistance, that is equal to feedback resistance by 2. So if that is the case, your output voltage will be Rf, instead of Rf I have to write 2R divided by R into all these resistance are equal to R. So if you simplify, you will get V0 is equal to V1 plus V2 plus V3. So simply adding all these inputs, the output will be equal to V1 plus V2 plus V3. If all the resistance are equal and that is equal to Rf by 2. Now let us recall what we have seen. A summing amplifier means it adds multiple input voltages and provides a single output voltage. Output is actually the weighted sum of all the inputs. There are two types of summing amplifier. One is the inverting amplifier and another one non-inverting summing amplifier. So inverting and non-inverting amplifier, let us see the diagram. So for inverting amplifier, you have to give the input to the inverting input. And if all the resistance are equal, the output voltage will be this one. In case of non-inverting amplifier, the voltages or input voltage is given to the non-inverting input. And if the resistance are equal, you will get the weighted sum of the input voltages. If you like the video, do subscribe to Read Electric Vehicle channel and share it with your friends. Thank you.